All right, in this video, we're going to explore a couple other properties of similar triangles. We've already seen how they have congruent angles and all of their side lengths are proportional. So in this section, we take a look at a whole bunch of other parts of those similar triangles that are also proportional. So that scale factor, we said that's the ratio of corresponding side lengths. It's the relative size of two similar polygons. If I'm looking at two triangles, if I know that they're similar, then that scale factor is also going to tell me the ratio of angle bisectors, altitudes, medians, and also the perimeter. So if I have the scale factor, I can take that scale factor and make that equal the ratio of angle bisector to angle bisector, or the ratio of altitude to altitude, or a ratio of median to median. Another thing, we can make it equal to the ratio of perimeters. This will actually cut down some work because if I know the scale factor, I really only need to solve one proportion to get the entire perimeter of maybe both triangles, instead of setting up multiple proportions to finding all of the side lengths and then adding them together. So that's kind of the big takeaway, or the first big takeaway from this section. So you can set up many more proportions than we previously thought that we could. Another thing in this section talks about when you do have an angle bisector, it turns out that that angle bisector is going to divide some parts of your triangle. So you're always going to run into the opposite side. So this is going to divide the opposite side proportional to the sides of the angle being bisected. So for example, let's say I have triangle ABC down here. AD, or I guess I need to fix my notes there, that CD should be an AD. So AD is an angle bisector of that triangle. What that means is AD is going to run into the side BC. It's going to cut that side into two pieces, BD and DC. Turns out that you can make a proportion with those side lengths. So BD to DC, those two blue side lengths or segment lengths, the ratio of those is the same as the ratio of the angle side lengths, so AB to AC. So I picked the BD on the left to go on top of that first ratio. What that means is I should pick the corresponding side length of the angle bisector to also go on top there. So just my apologies there on the typo. That should not be CD in that text there. It should be AD as an angle bisector. So this one's just a little bit different. It's different because you actually don't make two similar triangles. There's kind of a tricky proof that goes along with this one. I might show you all in class, but it gives us more proportions we can set up to find missing measurements. That's pretty much it for section 7.5.